Welcome to Class 10 Insight. 4 resistors, a voltmeter and a battery are connected in a circuit. So we have R1, R2, R3 and R4 along with the voltmeter and a battery. It is connected in a circuit. What is the net resistance in the circuit? We are supposed to find the net resistance in the circuit. It is very clear that R2 and R3 are connected in parallel. First, let us find out the equivalent resistance of these two resistors which are connected in parallel. So, let that equivalent resistance be called as R dash. So, R dash is equal to the formula to find the equivalent resistance for the resistors connected in parallel is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now, in 1 by Rp, we have R dash, that is 1 by R dash is equal to R1. In case of this parallel combination, R1 is nothing but, that is R1 is nothing but R2 and R2 is nothing but R3. Therefore, 1 by R dash is equal to 1 by R2 means it is 1 by 30 plus 1 by 15. The LCM is 30. Changing the numerators, we will have it as 1 plus 2. 1 by R dash is equal to 3 by 30. That is 3 ones are 3 tens are 1 by R dash is equal to 1 by 10. That is R dash is equal to 10 ohms. So this is the equivalent resistance of the resistors. Equivalent resistance of the resistors R2 and R3 that are connected in parallel. Now, this resistor R1, R dash and R4 are connected in series. To find the net resistance, we will be finding this equivalent resistance in series. So, we know the formula for equivalent resistance when the resistors are connected in parallel, that is Rs is equal to R1 plus R2 plus R3. R1 is 15. R2 nothing but the R dash, it is 10 and R3 is 15, which is equal to 40 ohm. Hence, the equivalent resistance or the net resistance in the circuit is 40 ohm. So, the answer for sub-question A is 40 ohms. Coming to the sub-question B. How much potential difference in the voltmeter connected across the resistor R4 measure? So, we have a resistor R4 here. We are supposed to find what is the potential difference in the voltmeter that is connected across this resistor. We know the formula. We know V is equal to I into R. Since we are supposed to find the voltage that is across the voltage drop or the potential difference in the voltmeter connected across resistor R4, resistance we should consider is R4, and also the voltage will be V4, for which we should know the current I. We should find the current I, that is the net current through the whole circuit. Why is it so? Because we know that when the resistors are connected in series, the current will be same through the whole circuit. So first let us find out what is the net current. through the circuit. Later on, having that value, substituting the value of the net current and the R4 value, the resistance along the fourth resistor, that is 15 ohms, we will be getting the value of potential difference in the voltmeter that is connected to R4. So first let us find out the net current, for which we have to consider the potential difference of the whole circuit and the equivalent resistance of all the four resistors, that is 40 ohms. So the net current through the whole circuit using Ohm's law, I is equal to B by R. What is the potential difference in the whole circuit? That is, I is equal to, potential difference is 20, R is 40 ohms. So it is nothing but 2 by 4, that is equal to 1 by 2, which is 0.5 amperes. So this is the current through the whole circuit, which is same among all the resistors. Now coming back to the question, we are supposed to find out the potential difference in the voltmeter that is connected across the resistor R4. So V4 will be equal to, what is the net current? It is 0.5 or 1 by 2 into R4. What is the R4 value we have? It is 15. So 15 5s are 75, and shifting one decimal point we get it as 7.5. Unit is V. Therefore, the potential difference in the voltmeter connected across R4 is 7.5 volt. Hope the solution is clear. Hope the class was helpful.